Hey guys, it's Mr. Thompson, and I'll be going over the projectile notes today. Some of you might have missed it, um, but hopefully this will help. So, first of all, when we're talking about projectiles, I need for y'all to understand that projectile is just an object in motion that's only affected by gravity. There's nothing pushing it up. Um, There's nothing pushing it down. It has no lift. It has no rockets to keep it moving. It's just an object in the air moving through space and time being pulled down by gravity. The path in which the projectile will move in this parabolic path is called a trajectory. So trajectory of the object is just the path that it takes. Okay. The next thing, really important for y'all to understand that the range of an object is the total distance it travels before reaching the ground. So let's say you have a super soaker at home, and when you bought it, it reads a range of 100 feet. Okay, so the water that shoots out from it, it's not going to hit a person that's 100 feet away. Instead, its range will hit the ground at 100 feet. So range is the amount it travels before it hits the ground. In this picture right here, this is the range from this point to this point. We call that the d of x, the distance in the x direction. Um, we went over the range is the total distance traveled along the x-axis. Just know it is known as d of x. D of x, aka range. How far did it move? So this is how a typical projectile would look if we took pictures of it in different intervals in its flight. The speed going this way will remain the same. But if you notice, these start clumping up together, the direction and the y. Why is that? Because as it's moving up, it starts to slow down, and right here at this point, it slows down enough going up, it stops and it starts coming back down. So at this point right here, the velocity is 0. So as the object moves up, it slows, it comes to a complete stop, and then it falls back down towards Earth. So the x velocity is constant, whereas the y velocity changes. It slows down, it stops, and then speeds up back down. But y direction is constantly being affected by the gravity. So take a moment and copy this diagram down. This will really help you out in understanding this. This is 10 meters going this way. At this point of the path, the ball is still going 10 meters per second this way. At this point, still going 10 meters, still going 10 meters, still going 10 meters per second. Whereas moving up, it might start off at 19.6 meters per second. It starts being slowed by the pull of gravity. Eventually, it stops altogether going up in the y direction. So right there, the velocity in the y direction is 0. And then it picks up the speed. Right here, the velocity in the y is increasing. Right here, the velocity in the y direction is decreasing. The whole time, the velocity in the x direction is constant. So these two, the velocity in the y, the velocity in the x, are independent of each other. Here's another nice formula you might want to write down. We learned this as how fast hitting the ground, but this is your velocity of the y. How fast does an object hit the ground? Well, this is the easiest format you're going to see. Only two things affect it. The gravitational pull on Earth. It is 9.8 meters per second squared. And how long was that object in the air? Okay, and that ranges. That is amount of time falling. So jot this down somewhere in your notes, and jot this down somewhere in your notes. We spoke of this recently, but you see after 1 second, its speed is 9.8. After 2 seconds, its speed is 19.2 meters per second. To 3 seconds, its speed is 29.4 meters per second. So if you notice, your speed is constantly increasing by 9.8 meters per second for every second the ball is falling. That acceleration is written as meters per second, or 9.8 meters per second squared. So what's the unit of gravity? 9.8 meters per second squared. Meters per second squared. So if the ball is in the air 10 seconds, the gravitational pull of Earth is 9.8. Its velocity after 9 seconds is 98 meters per second. So let's move on. I'm going to skip this real quick, but I do want to talk about this. Sometimes you will see v of x with an added 0 at the end, a subscript of 0. That tells you that this quantity is a starting value at 0 seconds. So at 0 seconds, right as we're starting the timer, that's the value to that. But in our class, in physics, we start off with, it's known, it's a given that we start off at 0. So we're just going to ignore that. Once again, use the formulas that I gave you on the board. I rewrote them to make them easier for y'all. Okay, here's a couple of things that you need to know. We're not going to get too detailed in this physics class, but just understand that if something is shot, something is kicked, something is launched, you have a velocity going this way in the x direction, you have a velocity going in the y direction. The soccer ball kicked off the ground is also a projectile, but it starts with the initial velocity that has both vertical and horizontal components. Luckily for us, we're not going to do the sine of the angle to calculate the resultant velocity, but just understand this part right here. You have two velocities. That soccer ball is going to have a velocity moving up and a velocity moving sideways. The sideways velocity, once again, will stay constant. This velocity in the y is going to slow, stop, and then start reversing direction towards the ground. Another concept I need y'all to understand is this. A ball launched at a steep angle will have a large vertical velocity and a small horizontal velocity. So, left or right, that velocity is very slow. But going up, that velocity is very high. Like a rocket ship. Or, I don't know, you're playing arrow roulette and you shoot an arrow up into the air and it lands back down. Straight up. Which, by the way, don't do that, guys. And it lands back down. A shallow angle has more speed going this way and less speed going that way. And if you're on baseball or softball, we're constantly told no rainbow throws. Straight throwing like this. You want all your speed to go in horizontal motion. If you're on first, let's say, and you're throwing it to third, you want that velocity to be aimed at a horizontal launch, not a vertical launch. Okay, so this is really important for us to, for y'all to understand. So please write this down. The range or horizontal distance depends on two things: how fast you're kicking it, and the angle at which it leaves your foot. If you play golf, how hard you swing it, and what club you use. Every club has a different angle. The best angle for distance is 45. It's always going to carry you the furthest. But if you look at 10 degrees and 80, it lands in one spot. 60 and 30 lands another spot. Anytime you can hit a target at a certain angle, you find a complementary angle, that angle is another angle in which you could hit that same target. Complementary angles equal 90 degrees. So I could shoot something at 20 degrees. And it's going to be pretty shallow. Could shoot it the same launch at 70 degrees. And it should hit the same target. So what did you notice about the 10 degree and 80 degree angle? They hit the same spot. They are complementary to each other. Okay. Skip that. That's a nice little assignment we could do in class if we had time. But we are going to do this. So, question B, and I skipped the other one just so, because I think I had more problems with this one. How far is your question? Your formula for how far is your velocity in the x direction times time. That makes sense. How far did you drive? Well, it depends on how fast you're going and how long it took you to do that. So you look up here, you see your velocity, you see your time. Multiply it, and you should get 60. Okay. We will continue the problems next week, but if we get to this part, I think we should be good. Just make sure you understand your variables and make sure you have your formulas written down somewhere. Thank you, guys.